So if you know me by now, you know that I love 3D printing, and if you've been watching my channel recently, you'll notice that a lot of the stuff that I've been showing off, a lot of the projects I've been working on, are to do with or have, incorporated in some form 3D printing. Now there's lots of upsides to 3D printing. It gives you a lot of control over what you want to make. It can make, perhaps geometries that wouldn't be possible with traditional techniques. You can make a lot of stuff using just one device as opposed to having a whole workshop with all different sorts of tools. But one downside of 3D printing is that it creates a lot of waste. Now if you saw my last video where I basically showed off a sort of adapter for an air pump for a algae culture, I still have that the raft and the support from that project, and I have a whole drawer of waste from 3D prints just like this, not to mention other stuff like failed attempts, stuff that wasn't perhaps within tolerance, and that sort of thing. I have a whole drawer of it. Now that presents a problem because while 3D printing is a very powerful tool, it also creates a bit of waste, as you saw, in the form of unused material. Now what people are left with is two options on how to deal with this waste. The irresponsible option is to just bung all your waste in the regular bin and hope it just somehow biodegrades magically in the landfill. The other option is recycling, which is helpful for a lot of plastic waste but not so much for 3D printing filaments like PLA, because a lot of waste collection schemes don't actually deal with PLA or similar materials. Now there has been a lot of research done and a lot of attempts by creators even on YouTube, such as channels like CNC Kitchen and Thomas Sanladera, who have created their own systems for recycling old waste 3D printing material into a new filament, giving it a new lease of life. Now whether it's small scale DIY solutions like filament making machines or more larger scale state-of-the-art recycling facilities, among environmentalists there's kind of a split between whether recycling is for better or for worse. Now I'm a bit biased here. I'm actually quite pro-recycling because yes, even though it does have some drawbacks which we're going to discuss in a bit, by and large what you're doing is taking old plastic materials, and not to mention other types of recycling like metal and glass as well, you're taking old waste that's just sitting there polluting the environment, doing basically diddly squat, and you're turning it into new usable material that can serve a better purpose. And you have to remember that plastic is everywhere in today's society, and it would be much better if we sort of took all of that plastic waste and sort of made it into something useful rather than just discarding it. It would be even better still to transform single-use plastics, that's stuff like food packaging and plastic wrappers and all that sort of stuff, and transform it into more durable, more longer term things that are going to last quite a while and be used for quite a long time. And that's where I think plastics have their niche in a sustainable world. Less and less so in single-use applications like food packaging, and more so in stuff like medical applications and engineering and things of that nature. But regardless of where you stand on plastics and recycling in general, they do have their downsides. And one such downside of recycling has come up in the news quite recently. It has been found that, I can't remember the exact numbers, But basically, even state-of-the-art recycling facilities that do their utmost to cut pollution and runoff and things of that nature, even they are found to emit a significant quantity of microplastics into their surroundings. Now, for those out of the loop, microplastics are classified as plastics that have an average size of less than about 5 millimeters or so per particle. And as the Guardian article, which I will link in the description, states, they can be as small as 5 microns in size. And that presents a problem because even if you try to filter out most microplastics, as these new state-of-the-art facilities are doing, some of those microplastics, the smaller particles, still manage to get through. And that presents quite a huge challenge for recyclers, large and small. Now, while the Guardian article accurately points out that the simplest solution is to simply reduce plastics rather than solely relying on recycling to save the world, there are a few technical sort of workarounds that we can sort of implement to eliminate the problem of microplastics. And we do need these technical solutions because the other option to recycling all the plastic that's out there is just to leave it in the environment where it will do much more harm than good. For those of you who are impatient, the short answer is that solutions to eliminate the problem of microplastics primarily revolve around similar techniques used for desalination. The absolute simplest way to stop microplastics from entering the environment through recycling facilities is to simply distill the wastewater. That way, all of the microplastic remains in the facility and all of the distilled water can be reused, and this sort of solves a double issue of water usage and emissions of microplastics. However, that comes with a quite a hefty energy cost, since especially if you're running this sort of setup continuously, especially on a large scale. Another method of collecting microplastics and filtering them out so that they don't enter the environment is through filters. Now, filters are already being implemented in state-of-the-art facilities and it's not working very well. Well, it might be the filters they're using, the type of technology they're using for filtration. Graphene has come a long way in recent years in terms of the ability for people to produce it, and one of the major breakthroughs in recent times has been something called Flash Graphene, where any carbon-bearing feedstock can be used to effectively make graphene in what amounts to the split of a second. Now, this requires specialized equipment, but the end result is graphene that's a lot cheaper than that made through other methods, such as electrochemical exfoliation. So, why are we talking about graphene? Well, as I stated prior, these microplastics are getting through these state-of-the-art filters, and some of these particles, these microplastic particles, are as small as 5 microns in diameter. Now, when we're talking about carbon filters, filters made of graphene, graphite, even stuff like activated carbon, and maybe perhaps even charcoal, I don't know, that might have too little surface area, but regardless, generally carbon filters of various types can absorb contaminants of all the way down into the nanometer range, which would be quite helpful in mitigating the amount of microplastics that get released into the environment from recycling facilities. Okay, so we have a few methods of removing microplastics and successfully blocking them from escaping into the environment. But what do we do with them once they start to mount up? Well, in the case of both distilling wastewater and filtering through microplastics through carbon filters and things of that nature, what can be done with these microplastics is something called pyrolysis. Now, we can't individually recycle every bit of microplastic. That's too impractical, because a recycling facility or a small batch recycling plant or what have you is likely going to use water to wash multiple different types of plastics, and they're all going to shed a little bit of microplastic. So the microplastics that you're going to end up with are going to be of a mixed variety. So recycling that is out of the window. So in lieu of recycling that, your next line of defense is pyrolysis. This involves heating any organic material in the absence of oxygen, and it's primarily used to generate various useful compounds that can be used for various applications, primarily fuels. There's tons of people online who've taken lots of PET water bottles and pyrolyzed them into a gooey crude oil like mass that can be converted into fuel. There's also been research done on turning algal biomass into fuel, and if this was to be applied to microplastics and it was done in a clean way, microplastics could serve another use as a feedstock for some fuels. Now, of course, I'm not paid by big oil, so I will say that yes, the primary way to reduce microplastics is for us to reduce the use of plastics, particularly single-use plastics and polyester clothing. The fibres can be a very rich source of microplastic fibres that get scattered all over the place. But anyway, that's just some news I read this morning and thought I'd give some of my thoughts on. I hope you've enjoyed the video. If you like what you see and you want to see more of my content, then why not click subscribe and turn on the notification bell. Thank you very much for watching, and I will see you next time. Take care, bye for now.